Okay, the last bit of 10.5, the last figure we're going to talk about are cones. And remember, cones are really a lot simpler than pyramids because a cone, again, is a three-dimensional figure that has one base, much like a pyramid. But it's always, that base is always going to be a circle. And that's because this is always a circle, it's going to be easier to find the surface area. Surface area, again, is the sum of all the area of the sides, and we split that up into base area plus the area of all the other sides, lateral area. And lateral area is the perimeter of the base times the slant height. So the perimeter of the base is going to be perimeter of the circle, and how to find the perimeter of a circle is just 2 pi r. And slant height, remember, the slant height is not the height of the whole thing. Slant height is here's my lovely cone. This is the slant height. This would be the height of the whole cone. If it was perpendicular to the base, that would be considered the height. But we're talking about the slant height. Okay, so perimeter of the base is 2 pi r L. So in the area of the base, this time we only have one base, and that's a circle, so the area is always going to be pi r squared for the base. So if you wanted to write this down, the surface area of all cones are always going to be base area, which is pi r squared, because it's a circle, one circle, and the lateral area is always going to be 2 pi r L. Okay, so that's an easy formula to remember, but in these problems, I'm not going to give you the slant height. We can still go ahead and work out what the base area is. So the area of the base, that's this circle at the bottom. We know it's a circle, so it's pi r squared, and the radius they told us is 8. So pi 8 squared is 64 pi. And like last time, let's leave our answers in terms of pi. Okay, the lateral area. We know lateral area is always the circumference times the slant height. We don't know what the slant height is, so the first thing you need to do is figure out what L is. And to do it, we're going to use Pythagorean theorem. So we know that the regular height is 15, the radius is 8, and we don't know what this is. And this is our hypotenuse because it's across from the right angle. So to find it, you're going to do 8 squared plus 15 squared equals L squared. And you guys are professionals at Pythagorean theorem by now, since we've been doing it since September. So 8 squared plus 15 squared. Oops, I didn't do it right. Plus 15 squared. And then square root it. I get that the slant height equals 17. So do your math. Make sure you get that slant height equals 17. Once you have that, now you can go ahead and plug it into the formula. 2 pi, the radius is 8. Now the slant height is 17. And let's leave it in terms of pi still. So 2 times 8 times 17. Just look at the whole numbers. I get 272 pi for the lateral area. And again, for the surface area, you take the base area, you add it with the lateral area. So I have 64 pi plus the 272 pi. And if you add up your whole numbers, you get 336 pi. And leave your answers in terms of pi. All right? So that's how you find the surface area of cones. Like I told you, it's easier. Go ahead and try to find the surface area of this last cone, CP and honors both. Okay. So one last thing I want to talk to you guys about. CP, you can try this one as well. I want to talk about what happens to surface area in any figure that we've talked about so far if you change the dimensions. And I also want to remind you guys what composite figures are. So surface area, what happens to surface area if you change dimensions? We've talked about prisms. We've talked about cylinders. We've talked about square pyramids and triangular pyramids. And we've talked about cones now. So we've talked about 4 different figures. And I'm going to tell you that something happens to all 4 figures if you change the dimensions. Something specific happens to the surface area. If you double the dimensions, we could do the work. But trust me when I say the surface area is going to be quadrupled. If you multiply all the dimensions by 3 for the surface area, trust me when I say this, we'll prove it in class, but trust me when I say that the surface area is going to be multiplied by 9. If you quadruple the dimensions, Anybody have a guess as to what that's going to be? The surface area is going to be multiplied by 16. So whatever you do to the dimensions, all you're going to do to figure out what's happening to the surface area is you're going to square it. Because 2 squared is 4, 3 squared is 9, 4 squared is 16. And the same thing happens if you aren't making it bigger, if you make it smaller. So let's say I half the dimensions. So I take the dimensions and I multiply it by 1/2. I cut them in half. What's going to happen to this surface area? Well, it's going to get smaller, but by how much? All you have to do is square it. So 1 squared is 1, and 2 squared is 4. So that means that the surface area is being cut by 4. Same thing for 1/3. Let's say I take all the dimensions and I cut it by 1/3. What's going to happen to the surface area is all you have to do is square it. And it's going to be 1/9. We're going to prove this in class tomorrow. Remind me in case I forget. I don't know why I wrote proof. Prove in class, the verb, not noun. Okay, cool. And then the last thing I want to remind you guys about is composite figures. Composite figures we talked about briefly for a DSAT already, DSAT, the mini DSAT, which you guys mainly did super well on. Composite figures are when you take two different shapes and you add them together. So for example, this house that I drew is a composite figure because it's made up of a rectangular prism on bottom and a pyramid on top. And what we're going to do is we are going to find the surface area of these composite figures. Sweet!